Good morning. Today we're going to practice using IXL, our solving trig equations lesson. So I'll do one per level to make sure that we can attack all sorts of problems. So let's start with level 0. The question says find all solutions, and in this case our solutions are going to be angles. We're solving for theta. Between 0 and 180 degrees. Give your answers in simplest form, and then separate them with commas. So, first thing, they're restricting right here. This restriction is telling me I need to be between 0 and 180 degrees. So, 200 degrees, 300 degrees, none of these will be part of my answer. That makes my life a little bit easier because I'll only have one answer instead of multiple solutions, as we've been seeing in the last few days. So given that we're only looking at quadrants 1 and 2, between 0 and 180, let's do our first step, which is to always label. My cosine formula is x over r. Now keeping in mind that negative cannot possibly belong with the r at the bottom because we know r is always positive. So that means I need to put my angle needs to be somewhere where x is negative. X is negative on the left side, usually in these two quadrants. But since quadrant 3 is unavailable, we'll draw our triangle in quadrant 2. My x values are negative on the left, drop the perpendicular, and now we're going to step 2, label our sides. So we know x is -1, this is the x side. The r is 2, and now using my knowledge of our triangle sides, I know this, even though it's tempting to say it's a 45, 45, 90, that involves a radical too. So I'm going to resist that temptation and remember that the 30, 60, 90 is the one with a 1 and a 2. So that makes that a radical 3. Now the important thing is to label our reference angle, the piece between our angle and the x-axis. Our reference angle in this case is across the radical 3, so I know it's 60 degrees. And we're one step away now. In our final step, we want to give our actual angle, which we always measure from 0, this way. So remember this little tidbit that we learned yesterday, or rather in our lesson this week, which is if we want to find theta and we're in quadrant 2, then all we have to do is take 180 degrees, which is this line, and then subtract our reference angle. So that's what I'll do. 180 minus 60 degrees gives me 120 degrees. And guess what? They're looking for the answer in degrees. So we're done. Now, don't take my word for it. We're going to prove to you that that's true. So we're claiming that if we took cosine of 120 degrees, we would get -1/2. Okay, that's the claim, but let's try it from scratch. So first, let's draw 120. 120 is in quadrant 2, and to find this angle, I do 180 minus 120. I find out my reference angle is 60. Drop the perpendicular. Across the 60 is a radical 3. That means this must be 30. It gets a 1 across from it, a negative. And our r is 2. Now the cosine formula is x over r. This is my x. This is my y and my r. So x over r is indeed -1 over 2. So we've proved, you can actually check your answer. We've proved that the angle we came up with, 120 degrees, is correct. You can hit submit and feel confident about that. So I'm going to bring these notes down for the next problem, but eventually we'll abandon them because it should become kind of second nature, the 1 radical 3, 2, and the 1, 1 radical 2. But it's okay if you still need the notes. It's been a little bit since we've been together. All right, so level 28. Find all solutions between -pi/2 and pi/2. Translation, remember pi is 180, so pi/2 is 90 degrees. and our angle should be between negative 90 and 90. So let's see first, before we do anything, which quadrants we can't work in. Well, if this is 0 degrees and this is 90 degrees, negative 90 degrees will open in the opposite direction. So that's negative 90 degrees. Now we can be between these two sides. So we are allowed here and here. That means we will not be working in quadrants 2 or 3. First step is block out your quadrants. Next, it says 10 sine theta minus 5 equals 0. Now notice this looks different from the problems we've been doing. So our first step is going to have to be to isolate the trig expression. So that means we're going to get sine all by itself, or if we had cosine, get cosine all by itself. We'll do that using regular algebra. So observe, we have 10 sine theta minus 5 equals 0. If I want to get sine by itself, well, what does it look like we should move first? And we should move the 5 over. Then we'll be left with 10 sine theta equals positive 5. And I'm still not done. I have this 10 being multiplied, so let's divide by 10. Equals 5 over 10. So really, sine theta equals 1 over 2. From this step, if you feel comfortable, pause the video and try it yourself. If you're a little hesitant, watch as I do it and try the next problem. So as we said before, step 1 is always label x, y, and r. Sine formula, sine is y over r. Next, I need to figure out which quadrant this is in. So notice that sine is positive, and since r is always positive, that means y must be positive. And y is only positive in quadrant 1. Out of these two quadrants, quadrant 1 will give me a positive y. So my angle can't be here. For those of you who are like, wait, I don't get it, you're just saying a lot of words. The angle can't be here because my y value would be negative 1. And then r would be 2. So if I put y over r, I'm going to get a negative 1/2. But I want a positive 1/2. That's how I know I'm looking for a positive y value. So let's label our sides. Y is positive 1, r is 2. And that means that, again, we're dealing with a 30, 60, 90 with a radical 3 on the x side. Next step, find your reference angle. Since we're across the 1, that'll be a 30 degrees. And then we find our actual angle. And notice that when we're in quadrant 1, there's no math to do. My angle is just 30 degrees. So our final answer is theta equals 30 degrees. Because we're measuring from here and opening that way. So it's just 30. Now notice that the question doesn't say degrees this time. So you're going to get the answer wrong and be set back if you put 30 in there. And if you see the pi, that's the indication that we'll need to do this in radians. So make a note to yourself, we're going to do this problem in radians. Well, 30 degrees in radians, if you've memorized it, it's just pi over 6. And that's what we would type in here. Pi over 6 radians, and we're done. So again, we're looking for solutions between negative 90 degrees and 90 degrees. Good. I know I'll be entering in degrees. That's one less step to worry about. So first, let's draw our quadrants. So which quadrants are we allowed in if we're between negative 90 and 90? If you said quadrants 4 and 1, then you're correct. It's just like the last problem. So we're not allowed to be in quadrants 2 or 3 again. Now notice our expression is pretty complicated, and that's okay. We'll just do the same thing as before. We need to get sine all by itself like this. The only way to do that is to move all our non-trig terms to one side and then keep our trig terms on the other side. Here's what I mean. 3 over 2 is a non-trig term. It doesn't have a sine, a cosine, or anything. So it's going to move to the other side. It will join this 5, another non-trig term. However, anything that has some trigonometric expression, in this case here, 3 sine theta and 10 sine theta, we're going to keep on the left side. So let's move our terms. Okay, so I want to bring my non-trig terms to the right, so I'll add 3 halves to both sides. I'm left with 10 sine theta equals 3 sine theta, and then that's minus 5 plus 3 halves. So I'm going to do that off to the side. I'll get a common denominator. That's negative 10 halves plus 3 halves, which is negative 7 halves. Okay, we're not done. We need to move all our sine terms to the left side. So since it's a positive 3 sine theta, I'll be minusing 3 sine theta. You kind of just treat sine theta like it's an x. If I have 10x and 3x, I'll need to minus the 3x to the other side. So minus this 3 sine theta. Notice that we're combining like terms. 10 sine theta minus 3 sine theta is 7 sine theta, and that equals negative 7 halves. I'm going to get rid of some of this because it's a little distracting. But if you haven't written it down yet, pause the video here. And let's finish the problem. I still need to get sine theta all by itself, so I have to divide both sides by 7. And here I'll divide this as well by 7. Whoops, I did something funky. Okay, I'll divide this by 7 as well. This gives me a complex fraction. We don't like to divide fractions, so let's put it over 1 and then multiply by the reciprocal, which will be 1 over 7. First thing I notice is my 7's cancel, so I'm left with, on the left side, just sine theta equals negative 1 over 2. And now we have it in a form that we can actually deal with. So sine is y over r, and negative will be with the y, because r is always positive. And which quadrant is sine going to be negative in then? Well, y is only negative in quadrant 4, so we'll draw our triangle here. R is 2, and this again gives me a 30, 60, 90 triangle with the radical 3 on the x side. Let's draw our reference angle. It's across the negative 1, so that's going to be 30 degrees. And to give our final answer, we'll do the math for quadrant 4, which is 360 minus 30. Leaves me with a final theta of 330 degrees. Sweet. Let's try a problem now without any notes. Okay, so again, we're going to need to manipulate this a little bit to isolate our tan theta all by itself. The first thing I'm going to do is minus the 15 on both sides. Next up, 15 tan theta equals negative 15. See if you can take the problem from here on your own. Equals negative 1. And we've isolated our expression, so we're ready to label. Tangent formula is y over, do you remember? Is it x or r? Well, if you remember SOHCAHTOA, we have opposite and adjacent, so that's going to be y and x, the legs. So we need to put this over 1. And now you might be asking yourself, whenever you see ones like this, is this a triangle, or is this one of our axis angles? So I want you to think carefully. We need to go where y and x are both 1. If you said we have a triangle, you'd be correct, because this is going to be a 45, 45, 90 triangle where both of the legs of our triangles are 1. 1, 1, radical 2. So indeed, this time notice that that negative can travel. It can be in the numerator with the y, or it can be in the denominator with the x. So normally, we would put it either where y is negative and x is positive over here, or where y is positive but x is negative over here. But recall, we're going to be only between negative 90 and 90 degrees. Negative 90, 90. So we will not be in this quadrant or this quadrant. By the way, that's Nealon in the background. He's having a doctor meeting. It's been kind of crazy with the coronavirus how all of the doctors are meeting on Zoom, and their shifts have been kind of crazy. So they'll work like 12 hours a day for 3 weeks straight, every single day. And then they have 2 weeks completely off so that if they've been exposed to the virus, they are then, they recover from it and come back and don't infect other people. But it is a little bit nuts, in my opinion. They're doing their best, but it's also scary, Anyway, I hope that your family is safe. Let's finish this problem. We want to know where, okay, so in this case, my x is going to be positive 1, my y will be the negative 1, and r will be radical 2. So my reference angle is going to be 45 degrees. Since we're in quadrant 4, see if you can figure out the math and your final answer. So quadrant 4 is going to be 360 minus 45 for this big angle. Actually, I just realized 315 degrees, if we entered it, will be a wrong answer. And the reason for that is the question wants between negative 90 and 90. So actually, we won't do our math like normal. We'll just call this negative 45 degrees, and that will be accepted. So I have to go back and change our answers here. So that 330 degrees, we'll actually just call it negative 30 degrees since they're asking for between negative 90 and 90. So actually this we have to call it negative 30 degrees because we're going backwards 30 from 0. And this answer is fine. And this answer is also fine. But yeah, the level 43 problem, we had to make a change. Okay, so we're nearing the end here. Let's do a couple more. The question wants between 0 and pi, so go ahead and draw your quadrants yourself. This is 0, pi is over here. We're only going to be between these two, so let's black out the quadrants we're not using. Did you get that right? Nice. I know most of you did. Next, let's isolate our trig expression. We can't have numbers all around it. We need to know what secant theta equals all by itself. So let's set it up. What should our first move be? Let's move the 12 by adding it. What should our next move be? Now we need to get secant theta by itself, so we'll divide both sides by negative 12. Leaving me with secant theta equals negative 1. Are we done? Yeah, we got secant theta by itself, so now it's time to label, as always. Secant formula is, take a minute, write it down yourself. R over x. I'll put this over 1. Now notice that the negative is currently with the r, but we know that that's impossible. So I'm just going to erase it and move it down here. It's still negative 1 overall, right? We didn't change the question, but that just helps me see that my x should be negative. So I know I'll be in quadrant 1 or 2. It will be in quadrant 2, where my x can be -1, label, and my r can be, wait a second, my hypotenuse can't be 1. Do you see the issue here? My x is -1, but then for the first time, I'm having a hypotenuse that's the same length as the side. Now, that's impossible. The hypotenuse has to be the longest side. And there is no triangle that goes 1, 1, 1. It's 1, 1, radical 2, or 1, radical 3, 2. So this is an impossible triangle. I need you to understand when you realize that this triangle doesn't work. So this is an impossible triangle. It's not going to work. But if it's not a triangle, it's probably an axis angle. An axis angle, one of these. So we need to figure out which axis. X is -1. Well, x being -1 is still going to be over here. So draw that as a point. And for all your axis angles, r equals 1. So we know we're good to go. By the way, prove to yourself that x is -1. What would that point be? Yeah, the point would be -1, 0. So my x is -1, the y is 0, but we only care about these two. So we're good to go. And we know that our answer then is either 180 degrees or pi radians. I know the answer is in radians because they told me to choose between 0 and pi. And notice that our answer does fall within the realm because it says less than or equal to pi, and our answer is equal to pi. So that's how we do our axis angles. That's our first one of the day, which is good to get that practice. Let's do the last problem. So again, focus here first. Which quadrants are we not allowed to be in if we have to be between 0 and pi? Pause the video and see if you can do this one all on your own. So here's 0, this is pi. We have to be somewhere between these two, so we're going to block out the bottom two quadrants. Next, we have multiple secant thetas. We want to get them all on the same side, and everything else should be moved to the right side. So let's begin. Again, pause the video and try it yourself. So notice I want to bring all my secants to the left, all my non-secants, these numbers, -6, 10, 5, to the right. So let's start moving them. I'll add the 6, I'll add the 6, and that will cancel it here. And I'll also add 14 secant theta in the same step. I'm lining them up with their like terms. And that will cancel 14 secant theta over there. Next step, -13 secant theta plus 14 secant theta will give me +1, or just secant theta. So these guys just became a 1, which I don't need to write. Equals -5 plus 6 is also +1. So again, we're done isolating. Now let's get started with our labels. Secant, as we said before, is r over x. Put this guy over 1. And now I want you to pause and ask yourself, is this a triangle or an axis angle? So triangle, you're looking for numbers like 1, radical 3, 2, or 1, 1, radical 2. If it's an axis angle, you'll know because none of these triangles worked. Well, the answer here is this is an axis angle. And how do I know? Because check it out, our hypotenuse is the same length as our leg. if your hypotenuse and your leg are the same length, that means you literally just have a line. It's not a triangle at all. Because a triangle, by definition, the hypotenuse has to be longer. So this is an impossible triangle. We have an axis angle. So the question then is, we have 3 possible axes. We could be at 0 degrees as our answer. It could be pi over 2 or 90 degrees. Let me label that pi over 2. Or it could be at pi. In which scenario is r equal to 1? Well, actually that's true for all of them, right? Just checking. So r equals 1 for all axis angles. So then our decision really boils down to, where is x positive 1? So think for a moment and pick your answer. So x is positive 1 to the right, so our answer is going to be right here on the axis. My x value is 1, the y value would be 0, and indeed r is equal to 1 on all our axis angles. So my only answer here is 0. And we can say 0 degrees, or we could say 0 pi. Since we're in radians, we could put 0 pi, but that's just the same thing as literally 0. And that's our answer. Hope that this video was helpful. Like, subscribe, and comment below.